Hello everyone, welcome to the Rhombus Energy Solutions webinar. Our webinar topic today is best practices for EV fleet operators looking to deploy vehicle-to-grid or V2G technology. Quick run through on the webinar agenda. So I'll do some introductory remarks and talk about a little about ground rules. That'll be followed by a presentation by Rick Sanders, CEO of Rhombus. A presentation then by Gregory Polazny, who's CEO of Nuvi. And then finally, we'll have Albert Burley, who's the Executive Director of Sales for Bluebird, do his presentation. Then we'll go through 3 panel questions. Each of those will be about 6 to 8 minutes long. And then we'll have an audience Q&A and a wrap-up. So for those of you who haven't used Zoom before, please put in your Q&A questions in the question and answer window. You can put those in as you see them, and then they'll just line up, queue up, and we'll go through them when we hit that part of it. Also, we're recording this webinar, both the recording of it, the audio-visual recording, and this PDF of the slides will be made available to everybody who registered for the webinar. Those should probably go out sometime tomorrow, so be looking for that. So if you missed it, don't worry about it. And with that, let me introduce the topic real quick. So our panelists, as I said, are Rick Sander. Rick is CEO and co-founder of Rhombus Energy Solutions. We also have Gregory Polazny. He is Chairman and CEO of Nuvi. From Bluebird, we have Albert Burley. Albert is Executive Director of Sales at Bluebird. And then I'm the VP of Sales and Marketing at Rhombus Energy Solutions, Mike Human. So what is vehicle-to-grid? So it's a question we get asked a lot. And the idea behind vehicle-to-grid is you've got a lot of cars out there that have energy in their batteries. They're just sitting connected to the grid, usually for charging, but when you hit peak hours, that energy could be used by the utilities to actually help flatten out their peak loads and also to help stabilize the grid. There's a lot of pieces to that. If you think about the process, what typically happens is an EV will return to a fleet vehicle yard, or if it's a case of a consumer's car, to his house. They plug it in. They have some energy left in the batteries, and they connect to a bidirectional charger. Then the charging infrastructure communicates with the grid operators, and it could be your electrical utility provider, it could be somebody in the market, depending on what your market situation is. And if the grid operator needs that power, they'll tell you to put the power back onto the grid, and then the system starts pulling energy out of the car or the vehicle and putting it back on the grid. And then when peak hours are gone, which are typically 5 p.m. to 9 p.m. in most metro areas, the EV can charge at super off-peak hours, which have significantly lower per watt-hour price. The whole idea, if you're looking at this from a fleet EV perspective, is this is a way you can reduce your energy costs by putting energy onto the grid when the price is high and then recharging when the price is low. Another way to look at this is kind of this nice pictorial here. If you think about what happens if you don't have vehicle-to-grid, people get home, they plug in their EVs, or they get done with their day of work with a delivery vehicle or whatever, or a bus. They plug it into the energy grid, and now that evening peak, which has always been bigger already, now gets much larger. What vehicle-to-grid allows you to do is to say, okay, I can plug in that car during, let's say we're talking about a school bus, during the time between the morning peak and the evening peak and charge it, or in these flattened areas in the back, and then put energy back onto the grid during either the morning peak, the evening peak, or both, significantly reducing energy utilization and the energy demand on the grid. If you look at this from an EV fleet, you think about it, if you think of, say, a car, and we've got a Tesla Model S here that we picture, it has about an 85 kilowatt-hour battery. That's about as much power as a U.S. home can consume in 3 days if it's fully charged. If you think about an EV school bus, and we have a Bluebird one here, which has a 155 kilowatt-hour battery, that can store nearly 5 days worth of power. And then a longer distance EV bus, this particular one has a 660 kilowatt-hour battery, can store almost 23 days of power. So even if you only have a small amount of that power left, it may be enough to offset significant portions of the grid and kind of represents money in the bank for an EV fleet operator. Okay, with that, let me turn it over to Rick Sander. Rick is, again, the CEO of Rhombus Energy Solutions. Rick, I'm going to pass you control right now.
All right. Thank you, Mike. Today, I have a few slides to share with you regarding V2G and some of the challenges we're all facing in deploying these systems, and why today, more than ever, V2G is gaining a tremendous traction in the market. Okay. Okay, one more time. The attraction of V2G at the 30,000 foot view makes perfect sense. It can help stabilize the grid during peak demand hours, offset intermittent renewable supply. It can significantly reduce EV fleet energy costs, as Mike has illustrated earlier, and it can provide a source of emergency backup. V2G is not new. It originally was conceived at the University of Delaware back in 1997. So the question is, why has it not been available until now? And why is it all of a sudden critically important and gaining traction? Well, for one reason, it's complicated. There's lots of different elements and different players that have to coordinate and work together to make the system work. EVs are finally becoming more popular, especially in the fleet area where there's a significant amount of energy storage on these vehicles, which compel an economic reason to have V2G. Performance is going up, cost is coming down, more and more EVs are being purchased. And third, depending on the use case, the economics are now incredibly compelling. If you look at school buses in particular, there's a number of days and times when they're not being used, and they have a tremendous amount of energy storage on them. And so now that is looking where the economics are coming into line, and it's making it incredibly popular. If you look at the next slide, you know, why is it challenging? Why does it take so much effort to get these to work correctly, and why hasn't it been adopted earlier? As I mentioned before, the V2G goes across multiple players and multiple functions, and requires a well-communicated and well-coordinated activity. You have the EV owner, you have the EV OEM, which may design the vehicle slightly different from one to another. You have the charger OEM, which in this case must be bidirectional in order for it to work. You have the software aggregator that plays the role of the kind of master communicating between these various entities, and Nuvei will give you a much better insight into that. And then you have the grid operators that play a role. And last but not least, you have a number of different standard groups which are evolving, but still completely not working together in one harmonious way. So how do we accelerate vehicle to grid, given that it's a compelling justification and the demand is increasing? Well, the biggest hurdle really is to get you know, all these various entities and standards to communicate and work together. There's grid communications, there's grid interconnects with a bidirectional power flow, there's the charger communication, charger standards, aggregators that work across all of these entities, and then there's the safety and security. If you can look at the illustration we pulled together on the right, and we loaded in what we know about, which are all the various standards that you have to look at and consider when companies are putting together these various components to all work together. But in the interim, without standards, large fleet deployments will drive forward, you know, using V2G because it's so compelling. And I think the companies leading that charge will set the standards of the future. So one of the elements, key elements for V2G solutions is the bidirectional charger. 95% of all the EV chargers that are installed and deployed today are unidirectional, meaning that they can take power from the grid and they can provide power to charging a battery. They can't allow power, they don't have the capability of controlling power and having a bidirectional power flow back to the grid, which is required for V2G. The bidirectional power flow is completely different than unidirectional power flow. It's more complicated. It's a little bit more expensive. It requires different hardware. It requires different software and firmware. And more importantly, it must go through a gauntlet of UL tests to become certified and be allowed to put power back to the grid. And that's a significant effort that any charging company that provides the charger must go through and meet these standards in order for power to be, pushed back to the grid. And lastly, who is Rhombus Energy Solutions? We develop and design advanced power conversion solutions, one to charger and transportation electrification. We also develop inverters for energy storage systems. We also do microgrids, and we do some customization in advanced power electronics. We're headquartered in San Diego. We have a large power testing lab in Dearborn and an Indian design center. Our expertise is in bidirectional, all bidirectional. So that's one of the reasons that V2G is important to us. Our products can be customized for specific OEMs and fleet requirements, and we've deployed over 820 systems worldwide. Thank you. Back to you, Mike.
Thank you. Thank you very much, Rick. Let me pass control over to Greg here. Greg?
Yep. Hey, Michael, thank you.
I'll let you know when you've got it. All right, you should be controlling the system.
Great. Thank you, and good morning, everybody. Thanks for listening in today. A great exchange around vehicle-to-grid technology. My name is Greg Brand. I'm the chairman and CEO of Nuvi. And at Nuvi, we make electric vehicle greener and affordable. We really have the only platform today that enables profitable deployment of EV fleets, and we do that globally. We are a spin-off of the University of Delaware, where Professor Willett Kempton was my partner in studying Nuvi, starting to actually work on vehicle-to-grid technology as early as 1996. We are headquartered in San Diego. We have offices in North America and in Europe, but 33 employees right now. We have some key IP that was obviously initially developed at the University of Delaware, and we have projects around the world. Our view here is to develop a worldwide platform that is able to manage electric vehicles in order to participate across a variety of energy markets, and I will try to give you more detail about it. And we started commercial operation nearly 4 years ago now in Denmark, where we have had vehicles participating into frequency regulation markets over the last 4 years, and so we've gained obviously a lot of experience through that. Today we have two corporate investors, EDF Renewable, which is part of the EDF group, and Toyota Tsusho, which is a trading company part of the Toyota group. We also have established a joint venture with EDF called Drive that is covering 5 countries in Europe, UK, France, Italy, Belgium, and Germany. Our mission is to lower the cost of electric vehicle ownership while supporting the integration of renewable energy for scalable and sustainable green society. Two trends. On the one hand, the renewable trend, which obviously reduces CO2, but it's very volatile from an energy generation, and therefore requires some buffer, and battery storage is a great way to do that. And then on the other side, electric vehicles that have a big battery inside, and that's really where the concept of vehicle-to-grid started from Willett Kempton's mind. It's really the idea that, hey, vehicles are parked, most of the time, 75, 80, 90% of the time. And if you add a little bit more electronics, power electronics inside the vehicle or inside the charging station, you're able to make the vehicle not only act as a load, but also give the ability of the vehicle to push energy back to the grid and to provide some type of vehicle-to-grid services. Then the next step is to actually have a platform that has the ability to aggregate those vehicles and to make them look like what's called a virtual power plant. Our platform has the ability to control bidirectional vehicles, V2G vehicles, in charging and discharging rates, but also we can combine that with unidirectional resources, so regular EVs that are only charging, as well as stationary storage. And then we can access a variety of market going from firming solar and wind on the generation side, participating into the wholesale market or supporting ancillary services at the transmission level, also participating into demand response program and providing voltage control, reactive power at the distribution level, as well as helping the end customer optimize their bill through time of use optimization or demand charge management. So to summarize, what V2G is really from Nuvi's perspective, it's really the ability of transforming electric vehicles that are unreliable load at the end of the distribution system. Unreliable because at any time the driver might come and plug his car or unplug his car, which creates significant volatility of the system. So to transform those unreliable assets into a reliable, dispatchable, monetizable asset. Reliable because we have the ability to establish the schedule on when the vehicle is going to be there, when it's not going to be there, what's the probability of the vehicle to be there or not at any time during the day. Dispatchable because we have the ability to control the charge rate and discharge rate on a second by second basis, and therefore provide a variety of services. And monetizable because we have virtual power plant capabilities that are really helping to access markets in the same way a gas plant would have access to those markets. So we can help stabilize the grid. We can enable an increased level of renewable penetration. And by providing those grid services, we generate some revenue that we can share with the vehicle owner in order to help reduce the cost of ownership of electric vehicle and therefore encourage the adoption of electric vehicles. Now, there are two other things that you need to do very well. The first one is the primary purpose of the vehicle is for somebody to drive it at some point. And so therefore you need to guarantee to the driver that they will have the charge level they would need or they want when they have to use those vehicles. The second piece is really about optimizing and protecting the battery that's inside the vehicle. This is not our battery and we need to take good care of it. A battery is not a linear system, right? Charging, discharging energy when you are between 50 and 70% or 40, 80% state of charge really has no impact on the battery life. Now, if you go 5% state of charge and a high temperature, you might have an impact of a few % reduction by doing it once. So the platform needs to be very aware of the battery it's dealing with, what are the characteristics, and what is the best area, the most resilient area of those batteries so that you keep on using them in that very specific area. We have projects around the world, as I said, on the bottom right here. Those actually our first customer in Denmark called Frederiksberg Forsyning. It's a utility in the city of Copenhagen. This is a CHAdeMO implementation, DC 10 kilowatt. I always describe those as like the cell phone in the 1990s, right? The big bricks that you had on the side of your head. The next generation of charging station is now a lot smaller. But those have been running for 4 years, and our customers are very happy of how they are working with us. Also in the UK, where we have some similar implementation, in Japan, where we are working with Toyota Tsusho, and obviously school bus deployments. We have already defined the projects around the US, and I will give you a little bit more detail in a couple of slides. Just to give a little bit more detail about the platform really is as a way to interact with the grid in different ways, either by communicating with an energy management system that would be related to providing some type of energy management locally to a building and helping reducing the bill, either by time of use or reducing the peak demand. And then obviously, and in this case, that's a saving to the energy bill. And on the other hand, also interacting with the grid, participating into markets, providing services that you can be compensated for. And those services then, by being compensated, then we have the ability to share a piece of that revenue with our customers and partners. System has the ability to aggregate a variety of vehicles coming from the light duty fleets, medium and heavy duty fleets. The advantage of creating a mix of resources is that it gives you a lot more flexibility in terms of the services that you can combine or you can provide to the grid. Really, it's about volatility, right? It's about how the system is able to face the complexity that that Rick was talking about before, but also the volatility, and really squish that volatility that the grid is facing, so that basically you try to get your peak to be as close as possible to your average. A few examples, and I wanted to set some ideas of values here, and those are based on real deployments. Building energy optimization. We've actually had a deployment in the Torrance School District for quite some time. We've been demonstrating with a 20 kilowatt implementation the possibility of saving up to $5,000 on the energy bill. Obviously, this is highly dependent on the building on which those buses are connected, or the load, more than the building, the load that those vehicles are connected to. But there could be significant saving, right? Demand charge are significant in California, for example, and there is significant value in doing that. Now, the ability also of providing services to utilities is a very important piece. The ability of providing some type of demand response program, helping basically utilities keeping their costs down depending on their business model, right? We have different type of utilities in the US, investor-owned utilities, publicly owned utilities, co-ops. But there could be very significant value in providing those services. And we are developing some program right now where on a over 100 kilowatt capacity per bus, there could be $20,000 of value generated by providing those grid services. Finally, accessing system-wide grid services that are usually managed by a system operator, like an independent system operator, is also a very important piece. This is how you can access the wholesale market. In California, we can do the two first. We are now working on establishing how we finalize the access to the system-wide markets. And I need to share that we've been working very closely with NSI. NSI has been a strong driver in the pushing for the school bus across the US. And so I want to thank them again, and National Strategies and our partnership that we've, the different work we've done with them have been really, really good. So just to finalize about the platform, there are different perspectives that you need to bring to the platform. There is an aspect around obviously how you're interacting with the grid and all the reporting that you have to do, but also interacting with the user is important, right? So a mobile app is obviously important. You are discharging the vehicle at time, and therefore it's very important for the driver to really be in control of it and say, hey, actually I've got an unplanned trip. This is something that I don't usually do, but I need to charge my car as soon as possible for now. So please stop doing any type of grid service and just charge me. There are many ways to interact with the user, but for us, we think it's very, very important to put that control into the hand of the driver. Also, integration, right? Integration with partners, as Rick said. Also, this is a very complex ecosystem. The ability of integrating with other partners around us is essential, and that's really what's at the heart of our platform today. Finally, reporting and monitoring 24-hour, helping. Also, it's about helping fleet managers to convert from internal combustion engine, which they've been used to do for many, many years, and to switch over to electric vehicles, which sometimes, there's a transition that you have to go through here. And so, we have established an offer, and you can find more details on our website in partnership with Bluebird. We've launched this offer with school districts with initially quite a bit of focus in California, but we see V2G is popping up really across the US. Utilities understand how V2G can help them, and really the school bus is what we call the killer app of V2G. So thank you very much, and please, if you have any question, don't hesitate to reach out to us. Thanks, Michael.
Thank you very much, Gregory. That was a great explanation of the solution. Let me turn it over now to Albert. Albert, let me see if I can get the mouse here. All right. And then next we have Albert Burley. Albert Burley is Executive Director of Sales at Bluebird. Take it away, Albert.
Thank you, Mike. Appreciate it. Good morning, everyone. Good afternoon to those dialing in from the East Coast. First, I want to thank you for the opportunity to share information about our electric school bus products. And I just want to review some history on our experience in electric-powered buses, where we are today, some information on the rapid growth in the industry and why, where we see it going, and of course, how V2G fits into all of this. So let me share a few facts about Bluebird's history with electric vehicles. We were the first school bus manufacturer to embrace EV technology, going back to 1994. That's when Bluebird collaborated with Westinghouse Electric Systems to develop our first battery-powered school bus. And in 1996, we provided 6 electric shuttle buses for the Atlanta Summer Olympics. This obviously was a very early adoption of electric technology, so performance was certainly not close to what it is today. And we didn't continue with those products at that time, but we certainly learned a lot during the development and the deployment. So where are we today? So just 4 years ago, we decided to develop an electric school bus for the school bus market and signed an agreement with Adamani and EDI. And also that year, we received a $4.9 million grant from the U.S. Department of Energy for the development and commercialization of high-powered V2G school buses. And by 2017, we launched our current iteration of the Bluebird electric bus at the STN Expo in Reno, Nevada. And in 2018, we started production and we delivered our first electric-powered school buses to customers in California. And so if we jump ahead to today, in 2020, we've really seen substantial growth in EV sales and are currently the only school bus manufacturer to have produced and deployed electric school buses in Type A, Type C, and Type D. And we recently announced that we have standardized on a CCS1 connector to allow either level 2 AC charging or DC fast charging. And we also now offer V2G as standard. And we're really leading the school bus industry with this new technology, so that's pretty exciting for us. So how are EV sales? Well, you can see from this slide that we delivered our first EV school bus in September 2018, and we delivered our 100th school bus only 20 months later in April of this year. And I'm happy to say that today we have surpassed 250 sales since we introduced the bus. So that's also very exciting, and it really hasn't slowed down at all this year, and we're seeing some substantial growth. So where have we sold our EV buses? Well, you can tell from this slide, we've sold electric buses in 13 states. That's depicted by the blue states on this map. And as you can see, sales are spread across many states with varying terrain and climates, ranging from very warm climates like either Arizona or California to like very cold climates, like you can tell North Dakota. So this illustration provides an overview of the electric components in our chassis. I'm not going to provide all the detail on these components in our Cummins power drive system, but I think this diagram helps depict why electric power is perfect for school buses. And that's really the available real estate for all the EV components, including the space required for large battery packs. And you can see from the diagram that the 14 lithium-ion batteries are mounted between the front and rear axles, where space is really plentiful.
Yeah.
So just looking briefly at kind of what's happening throughout the school bus industry with electric school buses, you can see from this small sample of headlines, there's an overwhelming demand from states and school systems to convert their diesel buses to electric power. And you're looking at some of these, as you might expect, California has been at the forefront of electric school bus adoption. And one of the recent grants from the California Energy Commission funded $90 million, which will result in about 150 electric buses and infrastructure going into California. And there's other states like Washington, Florida, New York, Michigan, and Vermont, just to name a few, are allocating significant funding through their VW Mitigation Trust and also other funding sources to make the transition to electric-powered buses. So what's fueling all this interest and growth in electric school buses? Well, first, like I mentioned, it's certainly available funding. The timing of the VW mitigation trust has lined up really well with the introduction of EV technology in school buses. So many states have either provided an EV carve-out to fund EV buses, or have mandated 100% of the school bus allocation be spent on zero-emission technology. And much of this funding also includes infrastructure as well. Now, second, reduced maintenance costs helps the total cost of ownership equation for, versus diesel. And I'll show you in a couple of slides, maintenance is really minimal compared to internal combustion engines. And these savings are in addition to the significant fuel savings realized from utility rates versus diesel fuel costs. Now, third, performance. I mean, besides the fact that electric buses have excellent performance compared to diesel buses, they also perform extremely well in various climates, both hot and cold. And I mentioned earlier, we have buses operating in very warm climates like Arizona and very cold climates, North Dakota, and they perform great in both. Now, zero emission is obviously a big part of what's driving interest and growth. And for us, our cargo is school kids. So the health benefits of zero emission are extremely important to our customers. You look at vehicle to grid, we've talked a lot about that. It lines up well for our customers due to several factors, but really the obvious benefit for school districts is the revenue that can be generated, which, again, really helps make that TCO equation work. And lastly, we talk about service and support. It's not really a driving demand in the school bus industry, but it's really a necessity for customers to feel comfortable in making the transition to electric, because this is obviously still new technology, and that part of it is extremely important. So, we touched on V2G as a component driving interest in electric buses from school districts, and we know it provides revenue back to the school, and it helps offset some of the higher upfront purchase prices. But, why are school bus fleets attractive partners for utilities? A lot of this has been touched on before, but really just reviewing some of this again, they're really a great source of distributed energy because their usage patterns are predictable. They're used early in the day and later in the afternoon, so they're idle midday when demand is at its peaks. They're also idle during hot summer months, again, when demand is high. And, because of the large battery packs, a fleet of buses can store significant energy. And this allows the utility to utilize these resources instead of wasting surplus energy from renewables or cranking up a natural gas power plant, for example. And also, again, to the point of buses being idle at the right time, nighttime charging of school buses provides really the most favorable utility rates. So we touched on maintenance savings earlier, but just here's a quick recap of why savings are so significant on an electric bus versus a diesel. Just to name a few of these, you have no engine oil. Of course, no engine oil filter to change. You have no air filter to change. You have no spark plugs or glow plugs. We don't have a transmission on our bus, so there's no transmission service required. And brake pad wear is actually a lot less, and that's due to the regenerative braking. So, but in total, you're looking at about an 80% reduction in maintenance costs versus a diesel bus. So what's our outlook for the EV school bus market? And, we believe it's going to be very, very positive. Interest in EV will continue to increase as the TCO equation becomes more favorable, and that's due to battery prices that will continue to fall, battery efficiency that will continue to improve, and really all these VDG projects that become a reality that will really help that TCO equation. And we see even more choices in bus sizes and capacities as optional battery pack sizes with varying ranges become available, and that will help meet more customer needs. And also improvements in EV cold weather performance to improve range and charging will increase the appeal of EV school buses to a broader base of customers than even today. Now, while available grant funding will likely decrease, we're seeing most states now disperse all their VW funds, so that, of course, will start to dry up some, but we expect there will be increases in funding from utilities going forward. And in addition, we kind of expect the development of more turnkey solutions that'll include financing, infrastructure, vehicle deployment, and maintenance to allow customers kind of an ease of conversion to electric buses from diesel power fleets. And that concludes my presentation. Appreciate the time. Mike, I'll turn it back over to you.
Thanks a lot, Albert. That was a great presentation. And now we're going to go into the Q&A session here. Our first question, and we'll just let the panelists jump in on it as we go. The first question is, how important will V2G be for EV fleets now and in the future?
Okay, you want me to kick that off, Mike?
Sure.
Okay. Well, certainly in the case of school bus fleets, we believe it's very, very important. If you think about the accelerating increase in distributed energy resources, the need for storage will also increase. The school buses are really one of, if not the best solution to this among the mobile energy storage options. I mean, if you're a school district, V2G revenue is an excellent way to further reduce the total cost of operation, which I've mentioned a couple of times. And if you think about it, in the event of a national disaster, in locating and deploying EV school buses as emergency energy sources is a lot easier than other commercially operated fleets. So just like what's happening now at the current moment in Louisiana, you can imagine this could be a major benefit in that type of situation.
So Mike, this is Rick Sander. I would say that it depends on the use case. I think for some fleets, and they're given their use case, it's incredibly important and will be used in the future. In other use cases, I believe that it may not pencil out. And so that will be determined when, the fleet operators, start to look at it and start to implement it. It will go through an analysis to determine whether it works or not, and whether it's compelling economically.
Yeah, I think it's Gregory here. To go along these lines, I think, it's a question of cost of integration of EVs on the electric system, right? And, when you have a fleet of vehicle that's getting implemented somewhere, the first 2-3 vehicles are pretty easy to implement and to interconnect to the system. But when you start to reach 5, 10, 20 vehicles, you need to have some much more advanced solution to do that. There's an upfront cost also associated with switching from internal combustion engine to electric vehicles. And when you put all that together, V2G can help you optimize your cost of energy on the one hand, but can also basically reduce the cost of the upgrades that are required, because you're able to generate some revenue by also doing those upgrades. It's not just about bringing the energy to the vehicles, but also providing those grid services. And so I think as we move forward in deploying more and more EVs, V2G becomes more and more important. And as at the same time you go down the experience curve and reducing the added cost that V2G creates in those deployments, you can expand the base of vehicles that can provide vehicle to grid. They don't have to be plugged as often as, for example, the school buses. And that's where, as you go down the experience curve, more and more vehicles can be V2G. And really the system at the end needs to work with all those vehicles, kind of helping each other and smoothing out the volatility that's otherwise on the system.
Thanks, everybody. That was a great answer. Let me get to the second panel question. We've had a few questions in the Q&A that address this as well, so maybe we can take care of some of those. And the question is, how much of a cost delta does V2G have versus unidirectional chargers, and how does it impact EV battery life? Rick, I don't know if you want to jump in this one first and talk on the charger side.
Yeah, I think on the first part of that question is the incremental cost of V2G. If you look at the cost of a electric vehicle, it is significantly more cost than the charger and or the software implementation. So I think it doesn't have a significant impact because the relative price increase of a bidirectional system with software is incrementally relatively small compared to the cost of the battery system. And I think, Greg is the best one to talk about the EV battery life.
Yeah, so on the battery life, I mean, a couple of thoughts there. One, as I talked a little bit about it, right? There are certain range, discharging a kilowatt hour doesn't impact the battery in the same way if you do that at 60% instead of charge, or if you do that at 5% instead of charge. So first is now understanding what is the most resilient area, and for the platform to really keep on using each and every vehicle in the best area of the battery is very important. The other piece is when you look at school buses, that are parked for sometimes a few months in a row during the summer. If you don't do V2G, if you let the bus park there, having a battery doing nothing for a long period of time is actually not good for the battery. You have deposition happening on the anode and the cathode, and therefore the battery capacity would be reduced just because the battery has been standing there and doing nothing. Whereas if you keep on using it during the summer and in providing grid services, you keep on charging, discharging it, and therefore you are actually keeping the battery healthier than if you were doing nothing, much healthier than if you were doing nothing. We've done some studies also with partners. There are some papers with Nissan, with Honda, looking at all the range of things that can impact the battery life. The number one is just time. Time is the one that's got the bigger impact on the battery life. Two is driving, because when you drive, you actually push on the accelerator. There are significant power going in, going out. And then when you have regenerative braking, you also have power energy going back into the battery as well. So driving up and down the hill is very similar to what you would do when you do frequency regulation, except that frequency regulation would be at a much lower power. And then fast charging, has some impact. And really V2G is very minimum. If you were to compare exactly same usage of a consumer vehicle, maybe V2G had 1% impact on the battery if you don't manage it at all. As I said, our platform manage the battery and make sure that there is no impact on the battery life.
Very good. Albert, did you have anything else you want?
Gregory kind of said it all, but I just would point out that, very good point by him on school buses being idle, certainly during the 3 months of the summer break. And that is always a concern with our customers, having buses idle that long, and how would that impact, degradation of the batteries. So we do encourage them to do what they can to exercise those batteries during that time frame. And, they're going to keep these buses, for 12 to 15 years minimum. So they're really interested in keeping that state of health of the battery as good as they can. So V2G obviously is an excellent way to do that.
Very good. Now let's go to the third panel question, and that is, what are the 2 to 3 best practices that you would suggest to a company considering deploying a V2G for their EV fleet? Gregory, why don't we start with you on that?
Yeah, I mean, I think that there is still, we are in the process of setting up the values, and therefore, the value might be different from place to place. So bringing in the right partner that really understand what is the value that you can extract in the local geography, making the decision in terms of the number of vehicles that should be V2G versus potentially those that should be just V1G is probably an important piece as well. And then there is a process, right? There is a process of interconnection that Rick talked a little bit earlier today. So my recommendation is there's a lot of noise around vehicle to grid. Make sure to work with people that really know what they are doing on the subject.
I would echo that. This is Rick Sander. I would echo that the key here is, because you're working across multiple different entities and different systems, what's critical is to select the best partner that can help look at all aspects and integrate the total solution for an EV customer.
Yeah, and the only thing I
Excellent.
think I would add to that, Mike, is they should also probably look carefully at not just vehicle to grid deployment, but also vehicle to building. I think that's kind of an important thing that they consider also when they're looking to get into this technology.
No, that's a good point. That's something we haven't talked much about here, but it's definitely of interest in a lot of school districts, especially where power can be an issue. So, very good.
Just
All
to
right,
emphasize on this, I think the idea of how you're combining vehicles and buildings, as what Albert was bringing up, is a very important piece. As I said, there is value in behind the meter services, and those there is no limitation on the regulatory side. But then there are many ways to do more to address different type of markets, and we are doing it today as Nuvi. So there are opportunities to do it today. It's ready today, but this is one thing I want to emphasize.
outstanding. So let's guys go to the panel questions, Q&A questions. I should say we've got about 40 of them. I don't think we're going to hit all those in the remaining 15 minutes, but I'll read them off as just kind of in the order they came in. And for those we don't answer, we'll try to answer in writing in the slides afterwards. So the first one is, if I want to go to V2G tomorrow in California, is that possible? I want you, Gregory, to take the first cut at that.
Yeah, no, this is possible, right? I mean, with the there's a very important interconnection requirement that's the UL 1741 SA, and this is what the latest charging station from Rhombus is able to do, and therefore you're able to go over this interconnection process. And then it's a question of accessing markets. You have different type of markets you can access today. As I said, you can either provide some type of energy optimization behind a meter, either through time of use or demand charge management. But there are demand response programs that you can access also today. And there are significant value in those programs. So yeah, this is ready to move today.
Very good. Our next question is, what standards are in place for interoperability among different vendors, and what standards are most needed to be completed? And I guess there's really at least two pieces of this. One is on the vehicle side, one is on the charger side, and probably on the aggregation side as well.
Yeah, I can do a first pass there. I mean, one of the issues is that standards are moving forward towards V2G, but they are not always fully established. And so that's why there is something that needs to be built above and beyond the existing standards. And that's really what we've been working on together with Rhombus and other partners in getting this done. Now you can talk to the charging station, you can talk to the vehicle. There are many ways to implement that. And I think in the long run, there will be different ways of getting this done as well. And so standards are being established and expect over the next 12 to 18 months, there will be full standards. In the meantime, we have ways to go around it and make this work.
Very good. Next question we have is, what fleet profiles coincide best with addressing the duck curve hours 17 to 20, which I assume mean 5 p.m. to 8 p.m. In U.S. time? And from my perspective, it's really, I mean, school buses certainly do, but if you look at delivery vehicles, they generally are available during those hours as well. People on delivery vehicles driving in their neighborhoods late at night. A lot of transport buses are as well. And
if I can add,
guys, what do you think?
If I can add something on that is, when there is peak traffic is really 25% of all the vehicles on the road at that time, right, during the day. So actually many vehicles are parked along the day. And so what's important is actually versatility of vehicles, and usage is really what is important here if you have the platform that is able to handle that complexity as well.
Absolutely. Okay, another question we have, this is for Nuvi, is Nuvi working with the New England ISO currently?
So we are not in the ISO New England market today. There are ways to accessing the market, and we know how to access the market over there. But there is also some Willett Kempton is actually doing some work at the legislative level there in order to establish rules that would make things easier. But there are ways to access the ISO New England market today, yes.
Very good. Another question we have is, and this one is panel outlook on if and how the industry is dealing with warranty risk to EV batteries used for V2G. In other words, if I use V2G, does that impact my warranty for my EV's batteries? Albert, you want to jump on that one first?
I think, I mean, warranties in our case, when you look at battery warranty, there is a maximum kilowatt throughput that's designated on the warranty. So obviously, you know, you have to weigh what that looks like when utilizing V2G to see how that impacts the terms of your warranty. But really, that's it from our perspective.
Excellent. Okay, let's see if I can jump to another couple questions. We have time. Here's a good question. Let's see if we can hit this one real quick, and then we can probably wrap it up. And that question is, what are the key distinctions between communication protocol for V2B versus V2G with a non-export arrangement where all power would be consumed by the facilities behind the microgrid be simpler to integrate? Greg or Mark, do you guys want to jump on that one?
Yeah, I mean, it would be simpler to integrate. Yeah, the issue, I mean, you know, our vision is really that you should have the ability to access all the value because it's very depending on the geography. And so having a platform that is able to catch value from wherever you go, it's important. Once you have a UL 1741 SA charging station, interconnection is not a problem. So really, you go above that. No, this new product from Rhombus is essential in order to go above and beyond that and to keep access to all those markets. I know that for people's mind, it's easier to understand when you control something locally. From my perspective, it's very important to be able to have a lot of flexibility in controlling those resources in order to keep the value that that resource can generate very similar, either you're in the UK, in France, in California, or in New England.
Yeah, I'd also
add,
add,
I think that's probably it. Go ahead, Rick.
Yeah, I'd also add that behind the meter it is a key element in certain use cases, especially if you have a large, say, a factory where you're consuming a lot of power during the day, and you may be, you know, exposed to peak demands. And so by having your employees or your delivery vans or whatever your vehicles are, electric vehicles, plugged in to the factory behind the meter, that can offset the factory peak demands and be quite significant.
Yeah, I think one could say that probably for V2H or any other V2X sort of solution, especially if you now throw in solar power as well. Right, it certainly gives the consumer a lot of options as to how they can use that, especially that battery storage as well. Well, with that, guys, I know we've got a lot of questions still. I'm going to try to get answers to these questions and put them into the minutes of the slides. But with that, I'd just like to thank Rick and Gregory and Albert for your time and answering the questions. And thank you, audience, for attending. As I said at the beginning, we will be sending out a link to the recording of this webinar as well as a PDF copy of the slides. If you'll see at the end, at the last slide here, if you have more information, if you want more information, feel free to contact any one of these three numbers. If you get the wrong one or one of these three links, if you get the wrong one, we'll talk between us and get you the right information one way or another. But with that, let me give you 5 minutes back to your day, and thank you very much for attending. And have a great rest of your week.